to example 7. In example 7, we're going to look at what happens when we get an indeterminate form that looks like infinity minus infinity. So in this example, let's try using a direct substitution to see what happens. So when I go ahead and plug in 1, I get 1 over ln of 1 minus 1 over 1 minus 1, which is going to give me 1 over 0 minus 1 over 0, which is going to be infinity minus infinity. Well, it doesn't really tell us much because we don't know if one infinity is going to win, if it's going to be positive or negative. It doesn't tell us anything. So what we need to do is do a little rewriting. And so we're just going to do a little bit of algebra. So here, just by combining like terms and finding common denominators, we can now have a different expression we can try to plug the limit into. So if we try to plug in 1, we're going to get 1 minus ln of 1 divided by 1 minus 1 ln of 1. So that's going to give me 0 over 0. Now this is indeterminate form. So if we ever get a limit that's 0 over 0, we can use L'Hopital's rule. So right here we're going to apply L'Hopital's. And we're going to get the limit as x approaches 1 of the derivative of x is 1 minus the derivative of 1 is 0, and the derivative of ln of x is 1 over x. And then here we need to use the product rule. So it's the derivative of the first one, so it's 1 times ln of x plus the derivative of the second, so it's x minus 1 divided by x. So now just doing some simplifying, we get this is the limit x approaches 1 of x over x minus 1 over x, all divided by x ln of x over x plus x minus 1 over x. And again, this is just where the fancy algebra comes in. And we have the limit as x approaches 1. This is going to be x minus 1 over x divided by x ln of x plus x minus 1 all over x. And so this is going to be now the limit as x approaches 1 of x minus 1 over x times the reciprocal, so x over x ln of x plus x minus 1. These x's are going to cancel. And this is going to give me now the limit as x approaches 1 of x minus 1 over x ln of x plus x minus 1. And so now we have something simple. We can try plugging it in. So if I do a direct substitution, I'm going to get 1 minus 1 over 1 ln of 1 plus 1 minus 1, which is still going to give me 0 over 0. So I have to use L'Hopital's rule yet again. So applying L'Hopital's rule, we get the limit as x approaches 1. This is going to be 1 in the numerator. And then I need to use the product rule. So I get ln of x plus x over x plus 1, which is going to be the limit as x approaches 1 of 1 over ln of x plus 2. And so now I'm going to go ahead and plug in 1, and I get 1 over ln of 1 plus 2, which is going to give me 1 over 2, which is 1/2. So sometimes you have to do some fancy algebra before you use L'Hopital's rule not only once, but maybe twice. On your own, I want you to try this problem. Determine the limit as x approaches 0 from the right of cosecant x minus cotangent x plus cosine of x. All right, let's see what we get. So if we try to do a direct substitution, we're going to get that this is equal to cosecant of 0 minus cotangent of 0 plus cosine of 0. And this is going to be 1 over 0 minus 1 over 0 plus 1, which is effectively just infinity minus infinity. So what we need to do now is do some algebra so we can use L'Hopital's rule. So by rewriting this, we get this is the limit as x approaches 0 from the right. And cosecant and cotangent for me are hard to work with, so I'm going to go ahead and write it in terms of sine and cosine. This is 1 over sine minus cosine of x over sine of x plus cosine of x. So this is the limit as x approaches 0 from the right. And this is going to be 1 minus cosine of x over sine of x. And I'm actually going to write this as two limits plus the limit as x approaches 0 from the right of cosine of x. And the reason I did that is there's no problem with cosine of x. It's just going to be 1. So when I try doing a direct substitution now, I get that this is 1 minus cosine of 0 over sine of 0. So this is equal to 1 minus 1 over 0, which is going to give me 0 over 0. So this means I need to use L'Hopital's rule on this part. So I'm going to bring this part down, and I'm going to use the L'Hopital's rule on it. So I'm going to get that this becomes the limit as x approaches 0 from the right, and the derivative of the numerator is going to just be negative sign, so it's negative negative, so you get a positive. So this is sine of x divided by cosine of x. And then this part we're just going to bring down. So when you bring it down, you get plus the limit as x approaches 0 from the right of cosine of x. And at this point, we're pretty much ready to plug everything in. Just do a little more simplifying. This would be tangent of x plus the limit as x approaches 0 from the right of cosine of x. And so this is going to be tangent of 0 plus cosine of 0. And so you get 0 plus 1, which is 1.